Alright, hello EECS 280. I'm Chris, and today we're going to review Functors in preparation for your final exam. So we're just going to go ahead and look at an example problem, and we're going to solve it together. We're going to go ahead and program a solution. So here's the goal. We want to be able to scale every element in a vector of doubles by some value. However, we need to scale it by various degrees in different situations. So we might want to double, triple, or even quadruple every element, or similarly, we might want to halve or third every element. Normally, we'd have to create a new function for all of these cases. So we'd have to create a double function, a triple function, a halve function, and so on, for every scalar we want to use. However, every function would be nearly identical aside from that one tiny computation, right, the scalar. So the question is there a better way to do this? And of course, yes, there is. We can use functors. So over here, I've got a bad example. In this bad example, I've gone ahead and written out each of these functions on their own. So we've got a v double, that's just going to double every element of a vector, and then the same v half and v triple, then also a print function just so that we can print our output to console. So in our main, we're declaring a vector of doubles, and those doubles in this case are just 1, 2, and 3. We're going to print it, we're going to double it in print, halve it in print, and triple in print. So let's see what happens. And as you'd expect, we start with 1, 2, 3, we double it for 2, 4, 6, halve it for 1, 2, 3, and triple it for 3, 6, 9. And that works. This isn't too much code, but there is a lot of repetition, and if we wanted to add more, we'd have to add, 5 more lines of code for each case we want to add. So if we want to be able to multiply by, every number, like any positive integer, for example, we'd have to create infinite functions. And that's just not ideal, right? So we're going to go ahead and look at how we can do this with a functor. So over here, I've secretly got the same print function and main function. We're going to go ahead and create these same functions, but in functor form. Whoops. Cool. So we're going to go ahead and create a class. I'm going to call it scale. And the only private data member we need for this is just a double that we'll call scalar. And that will be what we want to multiply by for a given function. And then in our public data members, we're just going to have a constructor, of course. So in that constructor, we're just going to take a double called scalar. We will initialize with an initializer list. And then the only other thing we need for our functor is an overloaded parenthesis operator. And that's going to enable an instance of our scale class to act as a function. So go ahead and call it, we can't call it anything, it's an overloaded operator, but we're going to take in a vector of doubles, and we're going to do that by reference, just that way we can modify the elements of the vector directly. Oops, double. Cool. And I'm actually just going to go ahead and copy what I've got in these functions. So all this is going to do is it's going to go ahead and loop through a vector with an iterator, and for each element it's going to multiply, well, it was 2, but now we just want to multiply by whatever scalar this instance of our scale class has. So now we can go into our main function and we can declare some instances of our scale class. So you can say scale, let's say v double, and we'll just make the scalar 2. And the same, we can say scale v half, make the scalar 0.5, and scale v triple, we can make the scalar 3. And then if we go ahead and run this, you can see it does exactly the same thing as our bad example did, but this is much easier to scale up, right? We only need to add one more line of code if, say, we want to quadruple every element, and then we can say v quadruple and run it. Oops, my bad. And that's all we had to do. Now we have a quadrupling function. So that's the benefit of functors. We can make like a class of functions that are all pretty much the same, but they all have this slight difference that we can declare when we declare an instance of our functor. So I hope that was helpful for you. Please let me know if you have any questions, and good luck on your final exam. See ya.